Hey, this is Raza from Shelly Automation, Product Manager for Mobile Industrial Robots. With the ability to now carry payloads up to 1350 kilograms, MIR can be utilized for a range of applications in a variety of industries from manufacturing to retail, and still be considered one of the safest AMRs on the market. MIR is transforming the landscape of material handling by eliminating the need for changes to your existing factory layout. Unlike AGVs, which mostly rely on external peripherals, AMRs from MIR utilize built-in safety hardware to simultaneously localize themselves in your facility and plan their route on the fly, accounting for dynamic obstacles in their environment. Although an AMR consists of much more advanced technology than an AGV, it's a more cost-effective solution designed with modern manufacturing environments in mind. MIR is highly adaptable for agile production and suitable for facilities of any size, which allows organizations like yourselves to break free from an inflexible AGV infrastructure and reteach routes as necessary. If you're constantly looking at ways to optimize productivity and efficiency, reach out to your local Shelly sales rep to help analyze your return on investment with deploying a fleet of AMRs and to better understand how they can help address your challenges with labor.
Hi, I'm Kevin March from Cognex here at the Shelly Automation Cambridge Lab today to show you our brand new D900 Edge Learning Classify tool. The Edge Learning Classify tool makes it easy to deploy deep learning solution without having in-depth knowledge of how to train a deep learning neural network. My application I'm talking about today is a wire harness connection. I'm going to look to make sure that the connection is made and to make sure the tab is engaged using example-based programming and the Edge Learning Classify tool. So the first step in my application is to locate the center of my module. Once I've located the module, I can then identify a region for my AutoLearn Classify tool. So in my application, I have 3 different scenarios in which that connector can pass or fail. First step in any deep learning tool application is to collect samples. So I'll enable my Collect Samples button and start to add images to my film strip. I'm going to add about 5 different images in different orientations for each scenario. So this is my first pass scenario. My second pass scenario is with the tab still engaged, but not fully seated. This would still be considered a pass scenario. The tab being disengaged is my first fail scenario. And my other fail scenario is the position of the connector. So connector not present on housing. So after I've collected my samples, I can then go into my AutoLearn Classify tool. From this window, I can go to my Training tab and start to create classes. It's important to note I can create multiple classes, not only a pass-fail scenario, but I can actually create multiple classes. So in this first class, I will call this No Good. And I can start to label these images. You label them by clicking the class. And what applying label means is the algorithm is now being built on the smart camera. So this is my first pass scenario. I can now create a class called OK. I go through and start to label each class of each image. And you'll see the algorithm start to identify, before you've even labeled the image, what it predicts the class should be. So in this application, this image here, you can see the tab is on this side of the housing, which means we have an OK condition. You can see my algorithm here is confident that this is a no good image. And as you continue to label images, the algorithm becomes more and more confident at labeling these images automatically. So the model health we're aiming for is above 90%. You can actually automatically identify images by class here. On the right-hand side, you have labeled images. On the left-hand side, you have unlabeled images with their predicted classes from the algorithm. So what you can now do is scroll through each one of the images, ensure that the predicted class is correct, which they all are here, and select multiple images for labeling. These are all considered no good, so I can apply that label. You now see my model health jump up to 95%. Let's finish our labeling by reviewing the other past scenarios that have been predicted by the algorithm, selecting them all, and applying the OK label. You can now see my model health is up at 97%, so let's go test the algorithm. Now I'm going to start to run fresh images into the algorithm to see how they react. That's a no good scenario. Here's the other no good scenario. My tab is missing. Now my tab's engaged. So you can see through the power of example-based programming how programming something like a wire harness connection can be made even simpler than traditional machine vision tools. The D900 is not only limited to deep learning tools, but has the ability to access all of our insight tools that you're used to seeing in our insight cameras. So applications like reading a barcode or reading a character on the module are all also possible with the D900. Thanks for attending the demo today. If you have any questions about the D900 and deep learning technologies, feel free to reach out to myself or any of your Shelly Automation representatives.
Hello there, it's James Sanker from Shelly Automation. I'm the product expert for Universal Robots and also your local automation and motion control product specialist. I'm going to be talking to you today about a few new solutions from UR with their partner Robotique. We're going to be demoing these products at future trade shows. We're going to be working with them in the lab. Our techs are going to be readily available to test your applications coming soon. So I want to go ahead and lay it all on the table and talk about some of the new neat features. So one of the coolest products I've seen as of late came out early 2021 from Robotique out of Montreal, Canada, is a screwdriving solution. It's an automated screwdriving kit that's a build-on for your universal robot to help with alleviating some of those tedious, dangerous, and sometimes time-consuming tasks. The screwdriving solution is made up of premium anodized aluminum. It stays very lightweight at 1.5 kilo, and it is very compact and easy to deploy. With regard to the solution, there's a hardware component, or two, and software components. We look at the hardware. We've got the driver, which fastens directly to the wrist of the universal robot. And we've got your screw presenter, or feeder, which is essentially a bull feeder type unit, which brings screws to a rail system, easily detected by the tip of the screwdriver. So talking about the tip of the screwdriver, it uses compressed air with a suction tip to get your screws repeatably from the presenter to the desired insert point. And with the software, it's really straightforward. It narrows it down to just two main functions with the Copilot for screwdriving, which comes on a nice little dongle for you. And so what it does allow you to do is easily program the pick based on the distance, based on the size of screw, and so forth, and the drive. So, how much torque you'd like to apply to that screw, the positioning, maybe some of the features to make sure that that is seated. So Robotique has really done a great job at understanding the application and giving you just the necessary features to get that done. So this is a great solution that I'd like you to come on by our lab soon to see. And perhaps you have an application, we can try it out and give you a cycle time estimate. With regard to the next solution, we're going to be talking about the Cnc Demo Kit, or the Cnc Machine Tending Kit, rather, which we have on demo in our lab. So the kit comes with some main hardware functionality that optimizes the cobot. It comes with handy gripper. It comes with a dual gripper. Let me put it over here. Comes with a dual gripper adapter. So you can imagine you can have a handy gripper on one end and one on the other. And this makes for seamless load and unload of your fixture or CNC jig. It also comes with one of these dongles as well. It's the machine tending co-pilot kit. Not seen here as well are the extended grippers. So if you have a larger part or smaller part, you can change out these grippers. They're just fastened there with a few screws. With regard to the software itself, we're looking at functionality to better utilize the force torque sensors. So the force torque sensors are built into our universal robot, but actually to enhance them, the software unlocks some capabilities. It gives you more finite resolution when you're going to a surface. So I'd like to detect where this object is. I'm going to have my gripper come down and actually come and rest and know exactly what force we're putting in to actually get the feedback and pickup of that item. Additional to that, with the force feedback, we can actually go in, and if this part was non-fixtured or essentially in free air and can move, we can go and drive to a known location and then start to move in a certain direction to understand when we contact that part, and we can offset the end gripper right there to easily pick up that object or part. Also additional to this, you can get a Robotique wrist camera. So it is essentially an integrated vision system right up in the collar of the robot prior to the wrist. And we would take a snapshot of your product, whether it be in a tray or fixture, and that will give us location offsets in XY so that we can adjust our end effector and transfer it to your jig or fixture. So those are some of the neat mechanical add-ons and programming enhancements Robotique brings to the table for universal robots. And that's going to be on display as well in our lab in Toronto and at future trade shows. There was one more thing I wanted to talk to you guys about as well. So when looking at bin picking, we do have a new value add partner who's bringing to the table a technology known as 4D bin picking. And it's really exciting. I'm going to allude to two things. It's going to greatly reduce your cycle time, and the ease of setup for bin picking is really, really fast. So it's turnkey. You just need to go ahead and set up 2 cameras, get it coordinating with your universal robot, and you're good to start bin picking. So these solutions all together will help you to enhance your plant, enhance your collaborative robot stations, and take some of those dangerous, injury-prone jobs like manual screwdriving, like loading and unloading of these dangerous machinery, and turn those around to have a collaborative robot perform that operation and have your operators do higher value tasks. So again, James Sanker from Shelley Automation here presenting Robotique and UR products ready to go in our demo kits. We'll see you guys soon.
Hi, I am Ankur Verma of Shelley Automation, the Pneumatic Product Manager. Today, I'd like to take the opportunity to showcase the Staccato FPU. FPU is the Flexible Positioning Unit. You can use this to turn any pneumatic actuator into a multi-positioner. We will be using this in conjunction with the SMC D-MP series of sensors. This is what's giving our feedback to the FPU to close the loop in this system. So I'll quickly power it on. We have pneumatic power, we have our feedback sensor connected, and we have predetermined 3 position sensors, 3 positions, 25%, 50%, and 100% of the stroke. So a quick turn, we achieve our position. 50%, full stroke. We can toggle back between all 3 and have 0.1 millimeter accuracy. If I want to take it one step further and have an analog command changing the stroke variable throughout, we go to our copy mode, which is this sensor here, which is giving our command signal now. And by changing the stroke, we have our positional feedback. Again, this works with any pneumatic actuator to multiple positions. If you have any questions, please contact your local Shelley SMC rep, and they can provide you with a demo. Thank you.